Hello students, welcome to our live APS classes, and as all we know that this is our foundation course especially for the students from 9 to 12. And in our today's live lecture we will start with a new chapter, and that is from the chemistry part, and this chapter is for class 12 and the name of the chapter is the solid state, and this is our part number 1. And in our part number 1 we will discuss important 25 MCQ questions or objective questions regarding this chapter. एंड ड्यू टू सम टेक्निकल प्रॉब्लम जो पहले वाला वीडियो था बेटे को लोड नहीं हो पाया है, इस वजह से दोबारा से इस वीडियो को मैं बना रही हूँ. सो लेट अस स्टार्ट विद आवर part number 1 regarding the chapter, that is the solid state. And this is the syllabus for the term 1 examination that is to be held in November 2021. And first of all, welcome to all the students who joined with us our live APS classes. And let us start with our first question regarding the chapter, that is the solid state. So everything that occupies space is known as matter. And there are three states of the matter, that is the solid, liquid, and the gases. Solid has definite shape and definite volume, whereas liquids has not definite shape but they have definite volume, and gases, they have neither definite shape nor definite volume. So these are the important characteristics of the solid, liquid, and the gases. And let us start with our first question regarding this chapter, that is how many space lattices are possible in a crystal. किसी भी स्पेस लैटिस में कितने क्रिस्टल्स जो होते हैं वो पॉसिबल होते हैं. हाउ मेनी स्पेस लैटिसेस आर पॉसिबल इन ए क्रिस्टल. किसी भी एक क्रिस्टल में कितने स्पेस लैटिसेस पॉसिबल होते हैं. ऑप्शंस आर 23, 7, 230 एंड द लास्ट वन इज 14. दैट मीन्स आपको ये बताना है कि किसी भी एक क्रिस्टल में हाउ मेनी स्पेस लैटिसेस आर पॉसिबल. सो बेटे किसी भी एक क्रिस्टल में जो स्पेस लैटिसेस पॉसिबल होते हैं दैट आर 14 स्पेस लैटिसेस आर पॉसिबल. लैटिसेस आर पॉसिबल इन अ क्रिस्टल, not 23, not 7, and even not 230, but only 14 space lattices are possible in a crystal. So here option D is the right answer for the question number 1. Now shift to the question number 2, and your question number 2 is the molar elevation constant depends upon. That means these are the colligative properties. So here the molar elevation constant depends upon. Options are either nature of the solute, either nature of the solvent, either vapor pressure of the solution, and the last one is enthalpy change. So here there are four options for the question number 2, and the molar elevation constant depends upon either the nature of the solute, nature of the solvent, vapor pressure of the solution, and the last one is enthalpy change. So here beta, the molar elevation constant, it always depends upon the nature of the solvent. Nature of the solvent, not nature of the solute, not vapor pressure of the solution, and even not enthalpy change, but only and only the molar elevation constant. It totally depends upon the nature of the solvent. That means the nature of the solvent, it is the most important characteristics of the molar elevation constant, and molar elevation constant totally depends upon the nature of the solvent. So here option second is the right answer for the question number 2. Now shift to the question number 3, and your question number 3 is the coordination number in hexagonal close packing is. Options are 6, 12, 18, and 24. So here the coordination number in hexagonal close packing is 6, 12, 18, and 24. So बेटा जो coordination number है especially in HCP, that is hexagonal close packing, is 12, not 6, not 18, and not 24. But जो coordination number रहेगा hexagonal close packing में, that is only 12. So here option second is the right answer for the question number 3. Question number 4. A crystal system with axis A not equal to a crystal system with axis A not equal to B, B not equal to C, and angles, that is alpha is not equal to beta, is not equal to gamma, and gamma is not equal to 90 degree. And it always corresponds to either monoclinic, B triclinic, third cubic, and fourth one is tetragonal. So a crystal system with axes A not equal to B and B not equal to C, and angles alpha not equal to beta, beta not equal to gamma, and gamma is not equal to 90 degree, and it corresponds to either monoclinic, triclinic, cubic, as well as tetragonal. So here beta, it always corresponds to triclinic. It always corresponds to triclinic, not monoclinic, not cubic, and not tetragonal. So a crystal system with axes A not equal to B, B not equal to C, and angles alpha not equal to beta and beta not equal to gamma, and it is not equal to 90 degree, and it is always corresponds to the triclinic. So here option second is the right answer for the question number 4. Next is the question number 5, and the question number 5 is for tetrahedral coordination, the radius ration R positive oblique R should be, option 1 is 0.155 to 0.225, second is 0.225 to 0.414, next 0.414 to 0.732, and the last one is 0.7321. So here for a tetrahedral coordination, the radius ration should be either 0.155 to 0.225, 0.225 to 0.414, 0.414 to 0.732, and 0.7321. So you have to choose the right answer for the question number 5. That is beta 0.225 to 0.414. 0.225 to 0.414. This is the right answer for the question number 5. So for a tetrahedral coordination, the radius ration should be 0.225 to 0.414. So here option second is the right answer for the question number 5. Next is your question number 6, and your question number 6 is the Wants-of factor accounts for, option is degree of solubilization of a solute, second is the extent of dissociation of solute, third one is the extent of dissolution of solute, and the fourth one is the degree of decomposition of the solution. So here the Wants-of factor accounts for, so there are 4 options for the question number 6. The Wants-of factor accounts for, and it is your question number 6. So here beta, the Wants-of factor accounts for the extent of dissociation of solute. So the Wants-of factor accounts for the extent of dissociation of solute, not the degree of solubilization of solute, not the extent of dissolution of solute, and not the degree of decomposition of the solution. But only and only the Wants-of factor accounts for the extent of dissociation of the solute. So here option second is the right answer for the question number 6. Now shift to the question number 7, and your question number 7 is what is the coordination number of sodium in sodium oxide? The coordination number of sodium in sodium oxide. Options are 6, 4, 8, and 2. So you have to choose the coordination of sodium, coordination number of sodium in sodium oxide. Options दी गई है 6, 4, 8, and 2. 6, 4, 8, and 2. So here beta the coordination number of sodium, in sodium oxide, that is 4. That is 4. So here option second is the right answer for the question number 7. The coordination number of sodium and sodium oxide is 4, not 6, not 8 and not 2. Rest are the wrong options, but only 4 is the right answer for the question number 7. Next is your question number 8, and your question number 8 is the empty space with HEP arrangement is. The empty space within HEP arrangement is option 1 is 34%, second is 47.6%, third is 32%, and the fourth one is 26%. So here the empty space within the HEP arrangement is, and it is your question number 8. So the empty space within HEP arrangement is 26%, not 34%, not 47.6%, and even not 32%. But only the empty space within the HEP arrangement is 26%. So here option 4 is the right answer for the question number 8. Now shift to the question number 9, and your question number 9 is which of the following is not an example of 13 to 15 compounds? Which of the following is not an example of 13 to 15 compounds? Options are LNSB, GAAS, CDSE, and ALP. So which of the following is not an example of 13 to 15 compounds? Options are LNSB, GAAS, CDSE, and ALP. And it is your question number 9. So बेटा इनमें से जो एग्जाम्पल नहीं है 13 to 15 कंपाउंड्स का, that is 13 to 15 compounds, that is CDSE. This is not, it is not an example of 13 to 15 compounds. So CDSE is not an example of 13 to 15 compounds. So here option 3 is the right answer for the question number 9. Now shift to the question number 10, and your question number 10 is osmotic pressure of a solution is 0.0821. This is the osmotic pressure of a solution, atmosphere, at a temperature of 300 Kelvin. Temperature of 300 Kelvin. So the concentration of moles per liter will be either 0.33, 0.666, 0.3 into 10 raised to power 2, and the last one is 3. So here if the osmotic pressure of a solution is 0.0821 atmosphere and at a temperature of 300 Kelvin, at that time the concentration in moles per liter will be either 0.33, 0.666, and 0.3 into 10 raised to power 2, and the last one is 3. So here the beta, the concentration in moles per liter, the concentration in moles per liter will be 0.3 into 10 raised to power 2. So here option 3 is the right answer for the question number 10. That is the osmotic pressure of a solution is 0.0821 atmosphere at a temperature of 300 Kelvin. At that time the concentration in moles per liter will be 0.3 into 10 raised to power 2. So here option 3 is the right answer for the question number 10. Now shift to the question number 11, and your question number 11 is the compound found in the nature in a gas phase but ionic in the solid state is. Options are PCl5, CCl4, PCl3 and POCl3. So here the compounds found in the nature in the gas phase but ionic in the solid state is either PCl5, CCl4, PCl3 and POCl3. So here the right answer is PCl5, that is phosphorus pentachloride. Phosphorus pentachloride is the compound that is found in the nature in the gas phase, but it is ionic in the solid state. So here the right answer is option A. Yeah, option 1 is the right answer for the question number 11. Now shift to the question number 12, and your question number 12 is some polar crystals when heated produce small electrical current. The phenomenon is called. अगर कुछ पोलर क्रिस्टल्स को हीट किया जाए तो वो स्मॉल अमाउंट के इलेक्ट्रिकल करंट को प्रोड्यूस करते हैं, एंड दैट फिनोमिनन इज कॉल्ड एज फेरोइलेक्ट्रिसिटी, सेकंड एंट्री फेरोइलेक्ट्रिसिटी, third pyroelectricity, and the fourth one is piezoelectricity. So these are the polar crystals, and some polar crystals when heated they produce a very small amount of the electric current, and that phenomenon is called as ferroelectricity, anti-ferroelectricity, pyroelectricity as well as piezoelectricity. So here बेटा अगर कुछ पोलर क्रिस्टल्स जो है जब हम उनको थोड़ा सा भी हीट करें तो वो स्मॉल अमाउंट का जो इलेक्ट्रिकल करंट है उसको प्रोड्यूस करते हैं, एंड दैट फिनोमिनन इज नोन एज पायरोइलेक्ट्रिसिटी. Pyroelectricity. So here option 3 is the right answer for the question number 12. Now shift to the question number 13, and your question number 13 is Fe3O4. Fe3O4 is ferrimagnetic at room temperature, but at 850 Kelvin it becomes diamagnetic, ferromagnetic, non-magnetic as well as paramagnetic. Fe3O4 is ferrimagnetic, especially at room temperature, but at 850 Kelvin it becomes either diamagnetic, ferromagnetic, non-magnetic as well as paramagnetic, and it is the question number 13. So beta Fe3O4 is ferrimagnetic at room temperature, but at 850 Kelvin it becomes paramagnetic. Paramagnetic. So here option 4 is the right answer for the question number 13. Now shift to the question number 14, and the question number 14 is which has the lowest boiling point at 1 atmospheric pressure. Options are 0.1 mole KCl, that is potassium chloride, 0.1 mole urea, third one is 0.1 mole calcium chloride, fourth 0.1 mole aluminum chloride. So which has the lowest boiling point especially at room temperature? ऑप्शंस दी गई हैं 0.1 मोल पोटेशियम क्लोराइड है, 0.1 मोल यूरिया, 0.1 मोल कैल्शियम क्लोराइड एंड 0.1 मोल एल्यूमिनियम क्लोराइड. So you have to choose the lowest boiling point at 1 atmospheric pressure. That is 0.1 mole